And as my colleague Peter Ballerstedt has said before, we evolved because we ate meat. Not to eat meat, but because we ate meat. And I just want to stress the importance of these meat nutrients on brain health and especially development, especially in the first 1,000 days of life. If people don't have access to those, it can cause really serious, permanent, irreversible damage. Okay. The next presentation is Nick Smith, currently a research officer at Riddett Institute, a New Zealand Centre of Research Excellence, hosted by Massey University. He now studies the dynamics of global food systems and their impact on the nutrition of the global population. Continuing on the theme of the role of meat in our development, he will be explaining the role of meat in global food supply. Welcome, Nick.
Thank you very much, Diana, for the introduction. And yes, great thank you to the organising committee for inviting me here to speak today. It's very nice to be able to join these sorts of summits in person after being locked away in little old New Zealand, bottom of the world, for many, many years now. Feels like many, many years. So, as mentioned, I'm an employee of Massey University, and the Riddett Institute that sits within Massey is really just a collection of food science and human nutrition researchers, around 100 across New Zealand, all working on those common themes. And within Riddett, my team that I work with is the Sustainable Nutrition Initiative. And our core focus is really, how do we feed people sustainably into the future, with a particular focus on nutrition. My disclosures, no, I'm not a meat scientist, I'm very much interested in food systems and come from a mathematical modeling and nutrition background. Received no funding from the meat industry, never have, just given a few talks. And as I'm seeing more and more people in this field doing, I feel I should declare that I do consume an omnivorous diet, if that's important to you to know. So why do we at SNI and we here care about nutrition? Why are we having this talk? Well, quite often I find, at least, that the debate around sustainable food systems really focuses in on the environmental impact and how we can remain economically feasible into the future. But both the UN definitions of sustainable food systems and of sustainable diets are really about delivering nutrition without compromising on the environmental, the economic sides. So nutrition really is at the heart of this debate, and we shouldn't forget about it. In this talk, I'm going to hopefully give you information on what the importance of meat is today to global supply of nutrition, how effective it is as a delivery vehicle for that nutrition, and talk through some future scenarios for what its role could look like. I'm going to rely heavily on a couple of papers. The first one at the top there is our own work in the Journal of Nutrition and in the development of the Delta model, which I will explain further in a moment. And the second is a recent publication in Lancet Planetary Health on global animal source food consumption, and obviously meat fitting within that. So first of all, our work modeling the global food system. So we developed the Delta model, which is a free online tool that we put up on our website so that people could understand how current global food production supports the delivery of nutrition to the global population, and what that might look like in the future if we change production or waste dynamics. So we look at total global food production and work out how much of that actually goes into human food as opposed to animal feed, losses and waste along the supply chain, or non-food uses. That allows us then to work out the total nutrients that are consumed in any given year. And lastly, we can make some bioavailability adjustments to that data to see what the bioavailable nutrition to the global population is. Now, I'm going to use the term bioavailability quite a lot in this talk. So a quick aside on what I mean when I say that. So bioavailability really captures that fact that if I eat as an example, 10 grams of protein from one food source versus 10 grams of protein from another, the value to me, the nutritional value, is not necessarily the same. Depends how easy that protein source is to break down by the gastrointestinal tract, how easy it is for us to absorb, and how the amino acid makeup of that protein matches our own body's requirements. Okay. So continuing with that protein example, why do we need to care about bioavailability? So what you're seeing here is the average per capita protein consumption, just mass of protein, in 103 countries that are the lowest protein consuming countries in the world. Color-coded by plant and animal, much as that is a poor split, it's illustrative here, and that horizontal line is average requirement. So if we adjust this picture for the digestibility of that protein, we get quite a different picture. Do I have an easy? Oh, I do, back and forth. So that availability has come down, and that decrease is largely in the green part of this chart, because in general, those plant sources of protein have a lower digestibility than animal source proteins. If we adjust again for utilizability, so this is how well those amino acids make up, I suppose, the pattern of amino acids in those foods match what we need, we come down again. Rock and roll that for you. So this is just really an illustrative example of why we shouldn't think about nutrition in terms of simple mass of nutrient consumed. Okay, different value depending on the food source. Now, our understanding of bioavailability of nutrients from different foods is quite limited. Our best understanding is for protein, and then we have a reasonable understanding for iron and zinc. Iron typically around twice as bioavailable from meat sources, so heme iron versus pulses, zinc around 1.7 times. But it's quite hard to work out in the human body how we're absorbing these nutrients, so a real challenge to understand. But we do include protein, iron, and zinc bioavailability in the Delta model. And this modeling approach allows us to see for today how important different food groups are for the supply of essential nutrients. So along the bottom of this chart here, we have 29 essential nutrients in the human diet. It's not all of the essential nutrients, but it's as far as we've got so far, and it's a very good start. Now, what you can see here is that the dominant color is green, right? So around 75%, 3/4 of human food consumption globally at the point of consumption is plant-sourced food. So as you would expect, the majority of our supply of most nutrients is coming from those sources. But obviously that varies between individual nutrients. You can see that big red wedge coming in from the left-hand side here. So that's meat's contribution to supply of nutrients. And the ones that are really that it's making the most impact to on the left are things like vitamin B12, some of the essential amino acids, fat, protein, vitamin A. And thank you very much, Professor Mann, for already explaining the importance of these nutrients, so I don't have to. So that's what supply looks like. And that's very nice, but it's far more illustrative, I suppose, to see what supply looks like in terms of what's needed. So if I adjust that same picture for the actual requirement of the global population, we can see relative importance. So that pink line across the middle there, that's what the world needs in terms of nutrient consumption. And then the bars show what's available color-coded by source. So for something like phosphorus, we can see there's a huge global surplus in terms of what's available from food consumed, compared to something like calcium, where there's actually a global deficit against what's required. To focus in on a few of these nutrients, so again, things like B12, vitamin A, protein, iron, and zinc. Several of these nutrients are very close to that global requirement line. So there's only just enough available in the world to meet the world's requirements. And we know inequitable food distribution is going to mean that there will be widespread deficiency. You can also see how critical meat is to the supply of some of those nutrients and what would happen to those bars were you to remove the red portion. So a quick wrap up of that opening. At the global scale, meat is really critical for the supply of certain nutrients, particularly some of the micronutrients that are already at risk. Meat protein is highly bioavailable and matches well with our bodily requirements. What I didn't show there is the split between different meat types. So in terms of ruminant meat versus pig meat versus poultry, it is pretty much a third split in terms of their relative importance, particularly for protein supply globally. Something that also wasn't there, but that I feel I should emphasize, is the importance of what some of us would consider byproducts. So the offals that come with meat production, really important for that supply of B12 and vitamin A, and should not be undervalued, as they certainly are in New Zealand. Yes, Nick, that's all very interesting, but that's just the global picture. We know there's variation within that. What does that mean? So this image here is unprocessed red meat consumption around the world. Now, while the average per capita intake globally is around 70 grams per day, that can be as high as 170 in parts of Europe and Central Asia, or less than 10 grams a day in, for example, India and other parts of South Asia. We also know that the preferred types of meat differ. We think about China, real big pork consumers, compared to South America, real big beef consumers. So there's variation in consumption, which, as you would expect, leads to variation in importance for nutrition. So let's take our same approach that we were thinking about for the global picture and focus in on individual countries. So what you're seeing here is dietary iron availability, again, after consideration of waste, non-food uses, all of that, against requirement for Ireland, the black horizontal line being requirement. So iron is actually slightly deficient in terms of supply for the Irish population, and a significant chunk of it is coming from meat. Compare that to somewhere like Indonesia, where that importance of meat for iron supply has gone down, seafood and plant source is more important. And compare to somewhere like India, almost entirely plant source iron in the diet. So the importance of meat really varies as much as intakes do. And this context is important when we're thinking about any changes to national consumption or supply of meat. What you're seeing here is nutrient gaps against requirement in those same three countries. So if we look at Ireland and the nutrients we typically associate with meat, we can see there's that slight iron gap, but no gaps for some of the others, compared to Indonesia, India, where we're seeing significant nutritional gaps for a lot of those key vitamins. So that matters when we're thinking about changes to consumption. If we were to reduce meat consumption in the Irish diet, it would make far more of a difference to iron availability than it would if we were to reduce it in the Indonesian or the Indian diet. Conversely, there's far more gains to be made in terms of nutritional adequacy by being able to increase nutrient-dense foods like meat in the diets of the Indonesian or the Indian population, as opposed to the Irish one. So that context is really important. Now, obviously, there's a cultural, an accessibility, and an individual choice element to this. Don't know really how feasible increasing meat intakes in India would be, but that context is really key. This table also hides some of the demographic variation. So when we're looking at total supply for a country, you don't realize that nearly half of the Irish women of reproductive age are actually getting deficient iron intakes. You can't see that here. We also don't see the fact that these micronutrient deficiencies are really, really important for children in South and Southeast Asia, where stunting, wasting, and micronutrient deficiencies are really high. So you need that demographic context as well as the national picture. And if we come down another level to the individual, how important is meat in the nutritional adequacy of individual diets? That gets really difficult, and really difficult for policymakers because it's so individual and dietary specific. We know that generally more educated individuals and those living in urban rather than rural environments tend to have higher meat consumption and better nutritional status generally, but there are exceptions to this, particularly in Europe and for certain meat types. And we also know that there's a higher burden of malnutrition in populations where there is lower meat intake. I'm not going to get into the causality element of that. I'm going to leave that to some speakers later in the day. So to wrap up this little section, context is really important, right? If we're making any recommendations or changes to meat consumption, we need to think about which individuals, which demographics, which countries that's going to impact, and whether that really fits with what we need from that specific population. Big leap sideways, away from people, and now I'm talking about cropland. So this is into that question of how effective is meat as a way of getting nutrition into people. Some big numbers up on the screen there, many of which I expect you'll have heard before, all out of the FAO, around how much cropland and how many crops are used in animal feed currently. The big one for me is a third of total cereal production going into animal feed. So when you see these big numbers, you immediately get the question asked of you, well, surely if we reduced meat production, that would mean there was more food and therefore more nutrition going into the human food supply, so that'd be better for us. But the answer is not quite that simple. So we can use the Delta model to look at these sorts of scenarios either today or in the future and see what they mean for nutrition. So here I'm comparing what the world was like in 2018 versus what it would have been like if there was no meat production, and thus all of that human edible feed is redirected into the human food chain. So what does that mean for energy and protein? Well, yes, there is an increase in the plant-sourced energy and protein available, largely from that cereal coming in. But it doesn't make up for what's lost in the disappearance of meat. However, as you can see from the black lines here, there was quite a surplus at the global level of energy and protein in 2018 anyway, and we don't actually drop below global requirements by removing meat. Note, protein is bioavailability adjusted here. And for some of the micronutrients, we do end up with a greater supply, particularly things like magnesium, folate, as shown here. So for some nutrients, yes, we do get an increase. For others, no. So B12, well explained by Professor Mann previously, almost, well, entirely from animal sources. So when we increase the plants in our diet and remove meat, we don't actually gain any B12. Vitamin A, we do get an increase in the availability of plant-sourced vitamin A, but not enough to make up for the loss from meat. Iron and zinc is a slightly more complex question. So the availability of those two nutrients doesn't change too much by removing meat because cereals are quite iron and zinc dense. However, what I've done here is I've adjusted the target intakes to match what the World Health Organization suggests intake should be on an entirely plant-based diet that doesn't contain meat. So while we have similar availability of iron and zinc, we would be needing to consume more due to those bioavailability constraints. So that's what an extreme no meat scenario looks like in terms of supply of nutrition. But yes, that is a really extreme example, and there are a few who are really advocating for a complete removal of meat from the system. Something that I know is very well talked about, particularly in continental Europe, is circular scenarios. So I'm sure you're well aware of what this means, but briefly, circular agriculture or circular food systems are where we remove that food versus feed competition. So all human edible crops go into the human food supply chain. Animals are fed on byproducts, waste, or grazing. Now, there's some really good work going on, particularly at Wageningen and Professor Hannah van Zanten's work on what this might mean in a European context. And they've shown that around a third of our protein requirements could be met by animal source foods under these sorts of scenarios. And indeed, our protein supply could be met There are some issues around a number of micronutrients, including things like B12, but this is very much an emerging and growing research area in terms of the nutritional delivery from these scenarios. Again, a note about context though. So thinking from a New Zealand perspective, which in this case will be similar to an Irish perspective, we're already quite heavily grazing dependent in terms of our animal production and low and quite sparse populations. And at least in New Zealand, quite a low amount of food processing to generate byproducts. We have very little, for example, cereal production in New Zealand. So there's limited change that could be made or potential for change, at least in our agricultural economy, towards these circularity principles. So you do have to think about local suitability. More work to be done, but certainly interesting. And the next question, hopefully to preempt one in the workshops, because it's usually the first I get after one of these talks, is, yes, Nick, that's all very interesting, and you found all of these nutrient gaps, but surely we can just fill those with supplements and fortificants, solve the problem that way. And indeed, that argument has been made a lot, including in the Eat Lancet report. They identify nutrient gaps. I believe it's B12 they identify in the Lancet report, but there are a number of other publications that I've listed here that identify gaps for a number of those key micronutrients and say we'll solve them with supplementation. But I'm really not aware of anyone who's had a good go at understanding what that looks like at scale. So what's the vehicle for delivering that supplementary nutrition? What's the cost either to individuals or to public health agencies of doing so? How bioavailable are those nutrients as supplements or as fortificants? And how acceptable is that sort of lifestyle going to be to a broader population? There are some really cool emerging technologies for this. For example, I did recently see, I must get this right, a method for fortifying salt with B12, iodine, iron, and folate. Really cool. At Reddit, they've recently developed a technology called FerriPro for fortifying dairy products with iron. Again, very cool and out on the market now. But horses for courses. Those sorts of technologies are fantastic in developed supply chains where we can easily build them in to production, processing, and then distribution. If you think about some of the more developing supply chains, and I had a really good conversation with a member of our team about this, you've really got to get in earlier. So you've got to think about biofortification of primary food crops if you want those nutrients to flow through the system. So horses for courses, as I say. Looking to the future, I will not step on Professor Wood's toes and talk about the high-tech solutions. He will cover that excellently tomorrow. But I would ask, in terms of nutrient flows, how do these technologies, let's say lab-grown meat, compete for nutrients or land in the same way that animals do? Large requirement for sugar, for example, going into these technologies, has to be grown somewhere. And what's their nutritional value, including bioavailability? Is that lab-grown meat going to have heme, iron, zinc, B12 in it in the same way that conventional meat will? Note on co-production. So things like dairy and eggs, and dairy in particular, really, really critical to nutrient supply globally currently. You could see meat as just a co-product or a byproduct of their production. We can't have one without the other, but they do serve quite different nutritional purposes. But should remember that connection, a systems view. And we often talk at SNI about overconsumption being a form of waste. So even though there might be nutrient sufficiency at a global or a country level, that's not being equitably distributed. And there are those that are consuming far more of some foods, including meat, than are really necessary for meeting their nutritional or health requirements. Again, later speakers will get into the health implications of that, but I would ask, to what extent is our production servicing that overconsumption? And to what extent is that overconsumption displacing other healthy foods? So an individual with really high meat intakes What's their dietary fiber intake like? Probably not great. What's their whole grain consumption like? What's that doing for health? And yes, addressing what the correct balance of plant-based but animal optimized will be, both for food systems and for diets. So I'm about to finish up. Hopefully I've convinced you or shown you what the importance of meat is currently to global nutrient supply, and that context is really important in that, because the picture is very different if we're talking global versus individual versus specific demographics. I also really hope I've convinced you, and I'm very pleased that nutrition got to head up this summit, convince you that nutrition has to be at the center of this debate. If we're talking about sustainable food systems, yes, we need to be environmentally, economically, socio-culturally sustainable. But if you're not feeding people, you're not sustainable. So nutrition has to be at that table. Only remains me to thank our core SNI team at the Riddett Institute in Palmerston North, and also our collaborators globally who help us come up with all of these results and disseminate them. Point you to our website if you're interested in things like the Delta model or these sorts of results, and say thank you very much for your attention.